Hello, welcome to the second video on Radians. So it's chapter 5, part 2, and this time we're looking at working with Radians. Essentially, things that you've done in year 12 whilst working in degrees, we're going to be doing the same things, but this time we're going to be working in Radians rather than in degrees. So you've seen many times how to sketch your graphs in degrees. You can do exactly the same for sine, cosine, and any other trigonometric graph, but this time work in radians rather than degrees. So your sine curve, for instance, would start at 0. We know that 90 degrees is equivalent to pi by 2 radians, so you're up to 1 at 90. Pi degrees is 0. Sorry, pi radians is 0. Sine of 3 pi by 2 is -1, and sine of 2 pi, we've completed the full loop, and you get back to 0. Again, the cosine curve, it's the same shape graph. All that's changed is we've got pi by 2 instead of 90, pi instead of 180, 3 pi by 2 instead of 270, and 2 pi instead of 360. If you'd like to pause me for a minute while you can copy down that sketch. All the rules that we've done in the past for sketching curves in degrees still apply in radians. So for example, if you swap the x for x over a in the equation of a curve, it stretches the curve by a scale factor of a in the x direction. If you swap y for y over a, it stretches the curve scale factor a in the y direction. If you swap x for x minus something, it translates it by the amount you're taking away in the positive x direction. If you swap y for y minus something, it translates it by whatever you're taking away in the y direction. So do you want to have a quick sketch of what you think this curve will look like? And if you pause me now while you do that. Hopefully you would have got the solid line, the solid curve for the cosine graph after the translation. So we started off, it's always a good idea to draw out what y equals cos x looks like in the first instance. That's the dashed line. And the way I think about it is, it's y is equal to cos, and in brackets, x minus negative pi by 2. Whatever I'm taking away, it tells you how you're moving that in the x direction. So because I'm taking away minus pi by 2, it means that I've got a translation of minus pi by 2 in the x direction. So each point, for instance, this point has been translated by minus pi by 2 in the x direction. So every point has been translated by minus pi by 2 in the x direction. Another thing that you've seen in degrees, and your teacher will have taken you through this, you're expected to know these off by heart. Your calculator does work them out for you. You will have been through at GCSE and at A-levels, drawing out the famous triangles and working out, for instance, that sine of 30 is equal to a half, cos of 30 is √3/2. So again, you're expected to know all of those off by heart. This time the angle's just in radians rather than in degrees. Okay, another task that you've done in year 12 and also at GCSE is when you've had degree measures, you've drawn out the sine or cosine curve and you've found a number of different values that work for a particular angle measure. So, for instance, you could use cos 4 pi by 3 if you thought in terms of degrees, that's the same as cos of 240. Okay, I would draw out the graph personally, and I'd look at where 240 is on the graph, which would be here because you're 60 degrees past the 180. Because you're 60 degrees past the 180, it's exactly the same as being cos of 120 because of the symmetry of the cosine curve, exactly the same as being 60 degrees in front of the 180. And we can see that cos of 120 is the same as cos of 60, which is one of the angles you're expected to know off by heart. But because you're 30 degrees past the 90, you're now below the axis. So you're the same height away from zero, but you're going down to minus a half. So whereas cos 60 gives you a value of plus a half, which you should know off by heart, cos of 120 gives you a value of minus a half. Okay, again, what's actually going to happen is you're going to have your calculators with you, so you can use your calculator to work these values out. You need to understand how the symmetry works of the curve, just in case you get questions that are involving algebra. There are different rules that you can use, different laws that you may have used in year one. The way that I tend to do this is just to draw out the curve and look at the symmetry of the curve. So again, I would think cos of 240, I would draw a line going across at 240, so cos of 240. I would realise that's the same as cos of 120 because of where the line goes across. I would realise from the symmetry of the curve that cos of 120 gives you a negative value, but it's as far away from zero as cos of 60 is above zero. And I know off by heart that cos of 60 is a half, so cos of 120 must be minus a half. Okay, you could similarly do sine of minus 7 pi over 6. You can draw out your sine curve and look at the symmetry of the curve, which is the way I do it. You can use your calculator for this particular one, or you could use the sine laws. On your calculator, if you press shift and set up, then angle unit, you've got a number of different options that you can choose from. If you're going to key in the radians directly into the calculator, you need to make sure that you've chosen the radian option in your calculator. Okay, so what I would like you to do now, if you could have a go at exercise 5B, questions 1 and questions 2, the bonus question 3. There's nothing that you've not seen before. The only difference is that all your angles are now in radians, whereas they were in degrees before. Thank you.